Good morning, mathematicians. Definitely still kind of sick today. I probably shouldn't be talking with my throat, but I've become a slave to the algorithm. And I do plan on recording and releasing an hour-long video later today. Maybe I shouldn't do that, but I do want to publish every Friday so that I can make that sweet ad revenue money. Presumably. I mean, who knows? Maybe I'll get 3 views. But what can I say? Beanie Boy in the building. That's me, baby. They call me Beanie Boy. Mostly because I'm sick and I'm just trying to keep my body warm. So today will probably be short, I'm guessing. I don't have the capacity to think very deeply right now. Good morning, Arad. So, we got this proposition here that we need in the proof of the existence theorem. You finally managed to fix your blog, so if you want, you can later check out the post on Tate's theorem. Yes, please do. Please do. Where's your blog? How do I find the blog? I should really start my own blog too, because I gave a talk on campus yesterday about some stuff about group extensions. Good morning, Ken. And someone was asking, I said I had all the details written up for my script for the next video in that series. And so I sent him that. But, I was thinking, I don't always write scripts, but for complicated ones I do. And I was thinking, I should maybe have a blog and upload scripts and stuff, or just written versions of certain videos. Okay, let K be a local field containing privative and iterative 1. Any element of K cross that is norm from every cyclic extension of K dividing N is an nth power. What the F? What the F? How is that even? Maybe that's not so bad. But it seems like a crazy thing at the outset. Oh, I've got to show its norm for every cyclic extension? I guess we'll see. Sharing URLs beating the machine? Wait, how did you share a URL? How have you beaten the machine? I don't see a URL. Arad, tell me your URL. Or tell me the name of the blog. What do I Google? Anywho, it's I think our old friend Quadratic Reciprocity secretly, right? Somehow this is this. It might be in live chat. I am in live chat. I am in live chat already. What's fan funding? Oh, I can make you guys pay. Ha ha ha. Yeah, I guess it got blocked. Yeah, it got blocked. You got to give us other clues. I don't know. Tate's theorem, math, blog. Yeah, I don't know. You got to give us more clues. Okay, so we define the symbol to be 1 if this has a non-trivial solution in QP and -1 otherwise. Wait, where did your message go? Did your message disappear as well, Boris? Google.com. I mean, yes. Okay. Clearly, obviously, anyone can see. Yeah, I know. Well, Rod, it won't let you post the link, but like certainly there are other keywords that you can tell us that I could put into Google to search. No. Depends only on AB modulo squares. Or what if you typed out some of the words in the URL with spaces and don't put a .com? Something like that. Oh, if I make him a chat moderator, how do I do that? How do I do that? Boop. Add as moderator. Can manage blocked words? Sure. Yeah, let's do that. Okay, Rod, you're big boss man now. See if it works. Maybe it will work. So anyways, this is the claim that it depends modulo squares. So, right? Okay, actually that is true. So it will descend to a pairing here, which is bi-multiplicative. Gonna ban anyone who trash talks Grothendieck. Yeah. What good is newfound power if you can't abuse it? Nice. Okay. How do I copy the message though? Yeah. Okay. There we go. Control C. Control V. Nice. Nice. Tate Nakayama theorem. Hell yeah. Hell yeah. Sweet. Define the notion of class formations and prove Tate's theorem. Prove that the objects of interest satisfy all axioms of a class formation by explicit computations. The object of this post is to explain the first step by stating Tate's theorem. Sorry. G is a finite group, and A is a G module, and we suppose that there exists an element in here such that for every subgroup, this is true, and the restriction is a generator. Okay. Then the conclusion is that taking cup products induces isomorphisms here. Okay. What is a class formation, actually? Essentially just a G module satisfying the assumptions of Tate's theorem. For the purposes of class field theory, this needs to be generalized to infinite and profinite groups. I mean, kind of. A Tia wall. Nice. Okay. We are interested in studying vanishing results by working one prime at a time. Vanishing is best understood in the following sense. A G module is cohomologically trivial if this is true for all integers and all subgroups. It should be easy to verify that induced modules are cohomologically trivial. I agree. The starting point is the following basic fact. Dark source. You want to learn what I am learning too. You're willing to study on your own. Can I give you a quick go-through? You're an undergrad student in CS. No strong mathematical background. Hmm. And you want to learn class field theory. Well, you definitely need to learn some group theory first. Yeah. Let me pull up my notes here. I mean, class field theory is, well, it's number theory plus algebra. Well, it's number theory plus group cohomology, roughly. So you'll want to understand specifically some algebraic number theory. And for this, I mean, since the notes I'm following are from Milne, it maybe wouldn't be a terrible idea to look at algebraic number theory, Milne's notes on algebraic number theory, but another standard reference is Marcus, number fields. Except he actually spells number. Something like that. The group cohomology, actually, I guess you could pick up from Milne's notes. I guess you don't need to go to another source, but this also definitely means you definitely need to learn some group theory. And probably you need to do this first because algebraic number theory is in part about understanding the algebra of Galois groups, which is relevant to number theory. So, yeah. What do I like for group theory? To be honest, I like Aloofy because it's an absolutely massive reference, but there's way more stuff in Aloofy than you would actually need. A book that I haven't pitched for a while that I used to see people saying was divisive on the internet is Gallian. It's not as nice as Aloofy, but what is nice is in between the little chapters, there's little mini biographies of mathematicians. So, yeah. I would definitely pick up some basic group theory first, and then maybe go look at Marcus. Well, by the way, and either of these books, Gallian or Aloofy, these are going to have things on fields. So you'll need to know some stuff about fields and groups. And then, as you're making your foray into it, you can start reading Marcus and just start seeing at what point you get confused. And then, I mean, if you read Marcus, you'll probably end up talking about modules, so it might not be a bad idea to have something like Aloofy on hand anyways, because then, you can go read up on the definition of a module or something. So I don't know if that is, hopefully that's a good enough start for you. But be aware that it is, from your current state, it is going to be a bit of a long road to actually getting to understanding class field theory. Very possible, and if you keep at it, you inevitably will get there. But it could turn out to be a lengthy journey. Apparently, some Langland's thingamabob is related to QFT too. Do I have any wise words about that? No, I absolutely don't. I'm vaguely aware of it. And I've read Frankel's, his pop math book. I mean, what's 300 pages of pop math? That's nothing. I have read that at one point. I don't remember exactly how it all ties into QFT. Mr. L had a question but forgot it. You thought people couldn't live without that knowledge? I'm not sure I understand that second statement. You had a proof of Riemann hypothesis, but forgot it. Damn. That one, that hurts. Galleon's a good book. I agree. Good intro book. Nice, mini, simple paper. Oh, about AN being simple. That's nice. There's an intricate balance in roadmaps. Got to go far back enough to gain enough motivation, but not too far that you'll never get to the end. Yeah, it's tricky. So that's why I do say, like, I don't know, open Marcus sooner than later. But, you know, you'll quickly find you don't understand a damn thing that's going on. But you'll see words like fields and groups, and you'll be like, okay, well, I guess I got to go back and understand what those are. You know, allegedly Schulze, who, you know, didn't even know how to, like, multiply matrices or something. And then he worked backwards from Andrew Weil's proof. He worked backwards from that paper and sort of went, okay, I need to know this definition, and went all the way back from there to the beginning and then built up. And that worked for him really, really well, obviously. Learned Galilean to learn abstract algebra in prison. Hell yeah. Well, Boris, you might, maybe you don't know, but actually I used to volunteer with the prison math project. And used to help, used to be a mentor to inmates wanting to learn math in prison. And there's definitely people doing fancy math in prison. It does help to be a super genius, but who knows? I mean, maybe that's what. How do you know that isn't what turned Schulze into a super genius? Maybe it was simply his methodology. You know, you're raw dogging graduate algebraic topology. Love to hear it. Barely any knowledge of group theory. Any advice? Yeah, I would say the same thing. I would say the same thing too. Is like, grab one of these books. Maybe if you're already doing algebraic, graduate algebraic topology, I would say go to a Luffy, and, you know, just as things come up in group theory, reference a Luffy. Reference a Luffy. Yeah. So I think you can go ahead with algebraic topology, but, you know, just be honest with yourself about where your blind spots are and make sure you're setting some time aside to be like, okay, they reference the fundamental theorem of the classification of finite abelian groups. I don't know what that is. Let me go spend some time reading the proof. Just read homological algebra in abelian categories. No need to worry about groups. Yeah. Yeah, that's true. Yeah, just do that then. Okay. Let's try and understand Tate Nakayama. Yeah, that's true, Ken. That is true. Yeah. Yeah. So maybe that methodology doesn't work for everyone. The starting point is the following fact. G is a finite group, then restriction to the trivial group, followed by transfer back to G, induces Tate cohomology multiplication by G. Ooh, the higher algebra version. Nice. At the same time, this must induce 0, since we're passing through the trivial group. Therefore, the order of the group annihilates cohomologies. So, namely, if G is a P group, then all of its cohomology is P torsion. Right. Alufi is good for real. Just blind recommend it, because I know bro likes categories. But you never read anything besides, damn it, my foot. Yeah. Well, the nice thing about Dummett and Foote is I think there's some actual representation theory in there. So, you know, maybe I should prefer that one. But I've never really... I have a hard copy of Dummett and Foote. I've just never spent a ton of time with it. Now, if G is an arbitrary finite group, we got a CeeLo P subgroup for each P. From the above, this restriction must kill all the non-P power torsion. Right. Moreover, if we restrict only to the P power torsion parts, then the restriction transfer composite. Wait, what's transfer? That's just inducing back up. Oh. Is an isomorphism. It's a multiplication by the index, which is coprime to P, hence invertible in. I know you didn't just write that to mean. Wait, is this p-adix? Is better? You better mean p-adix. I think you mean z mod p. That's heresy as far as I'm concerned. Corollary, if this for all p, then this. Aha. Because it's an isomorphism factoring through 0? Okay. I still feel like I need to write things out in more of a baby version for myself, but that's just me. But I feel like I understand this more. And Tate Nakayama's down here. Okay, we got some more reading to do. Oh, you do mean p-adix. Okay, good. You have not just p torsion, but arbitrary p power torsion, right? Yeah, okay. So let's look cohomology over finite fields. Actually, my throat is starting to get mad at me for talking too much. So I think I might cut stream off here as a short one. But I will definitely continue to read Arad's blog in the background. I hope you all will too. And maybe tomorrow we'll continue with the Hilbert symbol. Hopefully tomorrow I'll be better. Yeah. Okay. That's going to do it for today, gang. Go read Arad's